The structure of an atom. The atom is made up of three types of particle: protons, neutrons, and electrons. Protons and neutrons are found in a tiny central nucleus. Most of the atom's mass is concentrated here. Protons and neutrons are both sometimes called nucleons. The electrons orbit the nucleus in a series of shells, or energy levels. Mass and charge. The mass of a proton and a neutron are approximately the same. In comparison, the electron is so small that it is considered to have negligible mass. Protons are positively charged. Electrons are negatively charged. Neutrons carry no charge and are said to be neutral. Charge. The size of the positive charge on a proton is the same as that of the negative charge on an electron. This means that as the atom is neutral overall, the number of protons must be equal to the number of electrons. It is the electrical attraction between the positive nucleus and the negative electrons that keeps the electrons in orbit. Chemical symbols. All elements are represented by a unique chemical symbol. The atom shown above is that of the element sodium, Na. The atomic number or proton number of the element is equal to the number of protons found in the nucleus of its atoms. Since all atoms are neutral, this also gives the number of electrons in orbit around the nucleus. The mass, or nuclear number, is equal to the combined number of protons plus neutrons found in the nucleus of the atom. As each element has its own unique atomic number, it will also have its own unique electron structure. There are a set of rules that govern the filling of electron shells. These rules allow us to predict the electron structure of an atom. At this level of study, we look at the electron structures of the first 20 elements only, hydrogen to calcium. The electron shell closest to the nucleus is lowest in energy and fills first. This electron shell can hold a maximum of 2 electrons. Element number 1 is hydrogen with 1 electron in the first shell. Element number 2 is helium with 2 electrons in the first shell. The first shell is now full and can hold no more electrons. At lithium, the next element, the second shell begins to fill. This shell can hold a maximum of 8 electrons. At neon, the second shell is now full and can hold no more electrons. The next element is sodium, and here the third shell begins to fill. The third shell can also hold a maximum of 8 electrons. With each element after sodium, an extra electron is added to the third shell. This is seen for magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. With each element after sodium, an extra electron is added to the third shell. This is seen for magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. At argon, the third shell is now full and can hold no more electrons. The fourth shell now begins to fill at potassium. Finally, the 20th element, calcium, is produced.